So in this video, we are going to touch a very important aspect of data analysis and machine learning, that is exploratory data analysis, and the first step of exploratory data analysis, to be more specific. So missing the values, how to handle the missing values and how to identify the missing value in the first place. So that is the scope of this video. That is what we are going to discuss in this video. Before that, if you are interested in the written version of this video, that you want to have some notes handy regarding the topic, there is a blog available on my website, and the link will be there in the description below. You can refer the blog, and if you have any queries regarding the same, just comment me over there or over here. I'll be more than happy enough to respond to your queries, any kind of queries that you have. So having that said, let's just move ahead with our video, this session that we are going to have. So the first thing is missing values. So what are these missing values? First thing that may be coming to your mind is, what are these missing values? How does this missing values come from where these missing values have happened? So the missing values are when we are recording some kind of data, you are omitting some data to be filled for that particular property or feature. So it could happen in system enrollments, in data collection, or in surveys. So survey, as in suppose you are asking bunch of the people to give their health details for survey, and they don't. Many of the people don't really feel like giving all the details to the public. So in that case, the particular feature for which you want the information would remain blank. So that is a kind of missing value, or not a number value, in data analysis and data science project. So that's how your missing values come from any of the human error, like you by chance missed the values, you didn't put the values in the particular placeholder. So that could also be a reason of this missing value. So basically, this is how missing values are introduced into the data system that we are talking about now. So as we know, these are the missing values. I have this, as I talked about this earlier, this missing values is like we are having a data collection format, and then in that format we are missing some kind of values, like here you say 1 2 3 4 and then dash dash dash, some kind of missing values are there. So it could happen because during the people's people don't want to give any kind of information, that remains blank, or any kind of human error that remains blank. So these are some of the reasons which actually introduce the missing values inside the data set. So whenever we are getting the data, our first task is to identify these values. So these are the values we are supposed to identify. So before identifying all of these values, the first thing that we need to understand is, what are the data types? Well, we need to have all the data types in hand in order to understand how the missing values are happening, and how the missing values are incorporated, and how the missing values you could identify and handle them. So as I go to the categories, we will have different types of data in the data types. We will see the types of data for real after some time in the later section of this video, but for now let's just concentrate on what theory we are going to learn first, because theory, having knowledge is more important than when we are doing data science. Having knowledge is much more important than doing hands-on first. So that is something that comes secondary after you gain enough knowledge about the subject. So this is the categorical data. This is the discrete and continuous data. Categorical data is like, we have three kinds of data. Categorical data is the data that is something in the form of category or string. Like categorical data is like the duration of some action, let's say 30 months or 50 months, or the address of a person, or the IP address of a system. So these are all categorical data. Discrete data is something that is measurable, this mathematics score. If you are having a data frame which has a mathematics score of a student as a column, then that is known as the discrete data type. So continuous data type, which is like continuous, which cannot be measured, so that is known as continuous data type. So in each of this data type that you have to find, first of all, in case of categorical data types, as you could see, you have to find using this value count operation, you have to find what are the different sets of value that particular feature has. So based on that sets of value, you have to define what are the values which are actually null in the set of the values. So that is about categorical data. And about the discrete data, you have to get the, using this syntax, df call min and max, you have to find the mean and max of that columns. So these are some of the, before you go and do any kind of operations on the data, these are some of the things, stuffs that you have to record in your notebook in order for a better visualization. So we are talking about the visualization aspect only. We will talk about the handling part in the later section. So the minimum and maximum of the column is to be calculated for both discrete and then continuous data type. So for categorical data, what are the different sets of the data? For discrete and continuous data, what are the minimum and the maximum of the data is there? So that is what we are going to do for the data visualization. Now after that, the next step of the data visualization is doing a plots. We have to do a couple of plots in order to understand what is the distribution of the data. So that actually we will in this section we will discuss about the shape of the data. Like here you see we are having a disk plot of a particular column. Okay, this is skewed. As you could see, this is skewed. So you have to see how the distribution of the data is happening in this particular data set, whether it is skewed or whether it is centrally it is concentrated on the center. So if it is concentrated on the center, it is a normal distribution. So in that case, we should have different approaches for handling the exploratory data analysis, and if it is skewed, then there is a different analysis. So if you are having a like skewed, then you would in case when you are getting a null values in a data set which is already skewed, and the skewedness you actually got by plotting the disk plot of the particular columns, mainly the numerical columns we are talking about. So in case you find it is skewed, then the measure the replacement should happen with the median, with the median of the value. So all these columns will be having some values. Okay, and then what you will do is you will calculate the median of the column and put the null values then replace the null values with the median of the column. So that is that is the handling part that you are going to do. Before that, after you get this visualization, you will use this df is null sum to see how many null values are there in the column, in the particular column. So you can use it. So this value will particular give all the columns and the number of values that are there in the all the columns as null. So this was all about this plot. The next thing what we will do for the data visualization is create a correlation heat map. So heat map will actually give you some scores that ranges from 0 to 1. Okay, so if it is 1, it is highly correlated. So once it's a set of features, if these are highly correlated, then there is no point of having them all together. Okay, so you can have them removed if they are highly correlated. And the way you look for the highly correlativeness is through this heat map. That is through let's say like in this heat map here we are having this revolutionary utils, the top left 0.093. So it is very less correlatable, so it should be kept. So 0.74 total payment, it is highly correlatable. So all this marked in red, these are highly correlatable, so this could be removed. So that's how you should approach with the heat map. So the skewness and the is the first visualization, the heat map is the second visualization. The third visualization is of course a scatter plot. Now the scatter plot will help you to give you the relational aspect of the between the variables. So whether the variable is having, this is basically useful when you are trying to predict whether the data set has any seasonality or trendiness or not. Seasonality in the sense here of course in this scenario we are not getting any kind of trendiness or seasonality, because it is completely scattered. But most of the in some of the cases where the data are aligned like that, you will get it like a line ranging from 0 and vertically towards up, like that, indicating a positive linearity. And then there will be some spikes in between the two data points at a constant gap. So that is known as the trend. So that is, if that is the case, the data is changes at a particular time on a particular rate. So that is the seasonality and the trendiness. So you can use relational Seaborn, that is one kind of library available for Python users. So you can find the relation between two variables. Like here we have found the relation between the loan amount and the account annual income. The installments, whatever it is given, it's all scattered. So with this you can find, you can have different visualizations based on what parameters you are taking as x and y, and what is the hue that you want to take. So that is all about the scatter plots. The next one is the hist plot. So we got dist plot, we got scatter plot, we got heat map. Then next one is a dist plot. Dist plot, as I mentioned earlier previously, it is helpful for plotting out any kind of linearity and the trend and the spikes over here at constant interval of time. You could see the spikes. So these are the trends that is happening on a graph on a constant interval. So this is all about the hist plot. Now once after that, after having visualized, we got dist, hist, heat map, and then these are scatter plots. So we found that our once we found that our data is somewhat skewed, okay, and our data is somewhat non-linear. That means it does not follow any trend or any seasonality, and all the highly correlatable factors we have removed. We will see this in action in the later section. For now, this is what the scenario is. So later, after having done all of this, next thing that comes to in the queue is imputation of the non-seasonal and non-trendy data. Since we have non-seasonal and non-trendy data, we have to replace them with a median and mean. Now the choice of median and mean is again dependent on whether you are using this skewed graph or normal distributed graph. In case of skewed graph, we will go for the median. Normal distribution will go for the mean. So this is actually the format for the for replacing, that is df column fill now, df column median in place true. Same for the median part. So this is how you could use these expressions for replacing the null values in a data set which is non-seasonal and non-trendy with either median or mean values. So that was all about non-seasonal and then non-trendy. But if you have seasonal and then trendy data, then we'll go for the interpolation, linear interpolation, that will go. And the syntax for this linear interpolation is this: df interpolate method linear limit forward. You could also do backward or you could also do forward. So it will replace all the points with the interpolated values, that it counts. So that is what we are going to do in case of the data is seasonal and then trendy. After having that done, we will go for the, so yeah, it's the same thing, backward, forward, and then normal interpolate expression. So once you are done with that, we'll go for the categorical variable. So till now we have been talking about the discrete variables and continuous variables. So what we did is we found the minimum and maximum in the columns. Then we drew the highly correlated factors and removed them. Then we used the dist chart, his chart, and scatter chart to visualize whether it is skewed or not, or whether it is having any trendiness or any seasonality in their pattern or not. So based on that, we used whether it is median or whether we have to use interpolation. So that was about the continuous numerical variables and discrete numerical variables. But what about when we have this impute categorical variables? So here I have given two snapshots. So if you could see the verification status, previously it was 33, now it is 0. So 0, this 33, this is actually the categorical data is null sum value. So this is actually the categorical data is a data set which we will see in the coming sections, like how these things are actually happening. So this is the data set of categorical data set, and then we are calculating all the null values out of the columns. So in the verification status, we are having 33 null values, but after we simple imputed that one, it got 0. So what are the expressions we have used to have this done? So let's just see that. So this is the code that is required for the simple imputer. It is simply available in internet that you can use and go and get it from the documentation of the sklearn impute. So you are first using most frequently. That means any null value, if it is having, it will replace with the most frequent values of that among that particular column. Then you have to fit that for a particular column that you want to do, and then we'll have to transform the data. So this is what all you have to do in simple imputer for categorical values, for handling the missing values. Now once having that done, we will also discuss like KNN imputer. This is another way of handling this is the most advanced way of handling the categorical variables. Before doing that, we have to normalize the input and apply one hot encoding. Usually I don't go for this, because one hot encoding, like using get dummies and all of that, I have clarified this thing in a more particular way in my blog. The link you can check in the description below. So so here what we are doing is we are getting the impute, and then impute from the impute library, we're getting the KNN imputer, and then finding the three neighbors. Like it will choose the three neighbors of the dataset and transform the value of the null values based on that three neighbors value that it gets. So it was all about KNN imputer. So this was all about the theory. Now the next thing that we are going to do is we are going to hop on the practical value of how these things are getting done. So let's just check out our Jupyter notebook. Thank you. Hi. So in this video, we're going to see whatever we learned in the theory in the previous video. We will apply that in practicality. So here I've got this data set of fintech, which is a very popular data set, and which is the data set is also very huge. So I have loaded this data set, and I'm showing you this data set of all together. So that this much of rows and 151 columns, and we have, as you can see, we have got the member ID as the total. Entire column is not a number, and there are a lot of values, lot of columns which has not a number. So we need to handle this in this session. So let's just see how we can do that. So now that we have got an idea that the data has a lot of known values. The data is very huge. It has a lot of columns. So the first thing what we are going to do is we are going to filter out what are the numerical columns and what are the categorical columns. So these are the columns which are actually numerical or which are the categorical. So DF column, if you access the data frame over the columns, you will get the column, and out of that, out of the total column, you can access the numerical column using the get numerical data function. So you are getting this two columns, and then you are subtracting the main column with the numerical column to get the categorical column. So as you can see, these are all the categorical data, and numerical data is this. As you can see, these are all numerical datas. Now that we have a knowledge of about the columns, like which are the categorical and which are the numerical columns, the next thing is to check out a code to find out the categorical data set. So categorical and numerical data set, so you can use select D type on the data frame to get the numerical data and then get the categorical data. So this is the categorical data and this is the numerical data. We'll deal with the numerical data first. So let's just concentrate on this numerical data part. So member ID, loan, funding, funded amount, EINP, all these are numerical columns that we have to handle. So let's just see how we could do that. The first, because this data is very huge, so we can use PD options, display mean rows equals to any kind of rows that you want. I have used 115, so it will show me 115 rows at all without any this dot mention. So it will show me that much of columns. So the next thing that we are going to do is we have a numerical data set. So from the data set we created a subset of numerical data set. So after having created that, we will try to find out which columns has how much of null value. So as we discussed in the theoretical part, we'll use data frame is null sum, this part to find out what is the, okay, so I have not, let me just run this one. Okay, now I'm getting the numerical data. After having got that, okay, so these are the inside the numerical data frame, these are the datas, and these are all the as a result of this option being said, we could see all the columns over there and all the uh, uh, null values. Now you could see out of all the rows how much it is. 22 lakhs 22 lakhs and something is 22 lakhs 26,000. These are all not a number values out of the total rows that we got. So as you could see, the majority of the, like for this columns, the majority of the placeholders are nan. So you could also go and then remove it simply, but we have to follow a process. Like we have to understand where we can simply impute it and where we have to delete the values, delete the columns. So where we have to impute the columns and where we have to delete the columns. So before that, I'll just have a correlation matrix ready. So numerical data correlation apps correlation matrix this is. So this is our correlation matrix. Then it will show which are the highly correlated factors. So the first thing you got you got the data set, you will find the categorical columns, you will find the numerical columns. After having that done, you will create a sub data set which will be having categorical data set and numerical data set. In the numerical data set, you will find, because we are dealing with numerical data set over here, so in the numerical data set you will find how much of null values are there in particular column. So having that done, we'll go for the correlation matrix. So what we'll have to do with why we did this correlation matrix is we want to remove all the highly correlated factor to make this data set a little bit thin. Okay, so that's why we drew this correlation matrix. Okay, so this is a very huge data, so we cannot just look at it and identify which columns needs to be removed and which are highly uh, correlatable. So what we'll do is we'll define a process for this one. So I'll provide this Jupyter link notebook in my description below. You can find it, and you can find this is this function over there. This reduces memory. Since we are dealing with a high data usage, we'll have to reduce the memory. So this is what we are going to do, reduce the memory. And here we are going to, I have reduced the memory by 70%. So once that is done, the remove collinear feature. This is again the part where we are actually removing the highly correlated feature. So what we are doing is we are getting the correlation features, and we are creating a iterable iterable configuration, and then we are iterating through that iters, and then dropping all the correlated values and returning this value. So this is the value that is this is the values that we get after the all the correlated. So this is the data set that we get after all the highly correlated values are been removed. You can see the columns has been removed from 80, like one, it was like 100 something, now it is 82. Now that we have got our proper data set, condensed data set, so what we'll do, we'll again check what are the NaN values. So here I got what are the NaN values. Now the second process that we have to define is we have to find what is the percentage of NaN values in particular column. So for this I have created this code snippet. You can get all these code snippets inside the description below. Jupyter notebook description is all over there. Description, in the description box you'll get a link and you can access over there. You can also hop on to my blog, and there you'll get the link of all of this resources over there. You could plus you could also read the written format of what I'm saying right now for a better understanding. So what we are going to do is I have created this code snippet, and I'm calculating this sum, and then dividing it with the length, and then getting the percentage missing. Okay, so these are the percentage missing. As you could see, these are all 90 percentage null value, 95 above 90 null values, and above this is a completely 100% null value. So we have to define a process in which we have to remove all the NaN values if it is greater than 75%. If the missing values percentage is greater than 75% for a particular column, then we have to remove it. Otherwise, we'll have to impute it. So that is the process we want to define. So here this is another code snippet. My percentage is like 75, and this is the min count, and after that the min count, we are getting this min count, we are passing this threshold as the min count, and then we are getting this correlated again a condensed table. And here you could see majority of the NaN values have been removed. As you could see, majority of the NaN values have been removed. Why it has been removed? It has removed all the NaN values in which a particular column were having more than 75% of the NaN values as the NaN values and not any other values. So it removed those NaN values, but still we got to define another process in order to remove this in between interim NaN values, where the NaN values portion is less than 75%, so it could not be removed in the previous polishing state. So here what will happen is we'll just remove, since it is a skewed one. Okay, we'll take up this median and we'll use a filna operation on this particular column, and then remove the NaN value with the median value of that particular column. So we will do this in a loop so that it applies for all the columns that have the NaN value. So after having that done, we saw that now we are able to see that there are no NaN values over here. So we are getting 59 columns and there are no NaN values over here. So this is how the procedural way you could use for cleaning up your numerical data. For the categorical data, as we have discussed, we can use simple imputer, and we will be using that simple imputer in most of the cases. We have not discussed that in this scope, but this is a kind of task for you to handle the categorical data set that we described earlier. And you will also get the reference in the code section if you access the link. So this was all about the EDA analysis of numerical data set for missing values, for handling and finding out and handling the missing values. I hope you like the video. I mean, at first when I started with this, I first found it a little bit of messy, because when you are dealing with the data, like you things could get messy actually, because you are dealing with a lot of data points and individualistic data points that could behave in a certain way, or could or may not behave in a certain way, so that you have to predict. And then you have to also go through this process definition process in order to remove all the nans. Like if we have like for in this case, if we have removed the adopted the median value first, then it would not have gotten us the correct result, and it would get in this case after the proper removal for by finding out the missing values percentage and then removing that, and then uh, finding out the median of the particular column and then replacing it. So there are some steps that we need to follow and go through the steps in order to get this done, and of course it will take practice. So just practice along with this. I'll provide all the links of this Jupyter notebook in the description below, so you can access it, and I hope it helped. Thank you.